This video will help you with connecting exponential graphs with context. So our situation, carbon-14 is an element that loses about 10% of its mass every millennium, which just means every 1,000 years. A sample of carbon-14 has 600 grams. Which graph shows the sample's mass y in grams after x millennia? So immediately I'm seeing that it's starting at 600. So this graph starts at 600, which is good. This graph doesn't, so it's not good. This graph does, so it's good. This graph does not. It starts at 500, so it's not good. So we're thinking either A or C just based on our starting point. So it starts at 600, and if it is losing 10%, so it starts at 100% and it loses 10% each year or each millennia. So that means only 90% is remaining. So that's going to be what our decay factor is. Now remember, we have to type that 90% as a decimal, which is 0.9 to the x power. Now I'm going to zoom out a little bit and I'm going to see how quickly my graph is dropping. So I start up here at 600. Oops. And then if I look at this graph here, once it hits 2, it's really close to the x-axis. So I'm going to type x equals 2, and I can see that this graph is all the way up here, like pretty high up here. So it's not really close to the x-axis. So that means C is going to have to be my answer because my graph just is not dropping as quickly as A is showing. So it's going to be C. Okay, now this one says a certain medicine is injected. After a certain medicine is injected, its concentration in the bloodstream changes exponentially over time. The graph describes the medicine's concentration in milligrams per liter over time in hours. So this is the concentration Y. Time is always X, is going to be on my X-axis here in hours. How does the medicine's concentration change over time? So we have a few options here. What I want to do is see what happens after 1 hour. So when 1 hour is left, or after 1 hour passes, I see that there's 70% concentration. So time is 1 hour, concentration is 70%. A says the medicine's concentration drops by 30% each hour. It looks like that's exactly what happened. It went down by 30% after an hour. The medicine's concentration increases by 30% each hour. Nope, this is a decaying function. The medicine's concentration drops by 70% each hour. If it was 70%, I would have a point down here after an hour. So it's not going to be that one. Or the medicine's concentration increases by 70% each hour. Cannot be that one because this is decaying. So that means A is the answer for me. Use this video to help you with the rest of the problems. Make sure you're looking at what the question is asking. So like down here, it says, what's the computer's initial price? Well, I know that the initial price is going to be my y-intercept. So for this one, it has to be $500. So just making sure, again, we're tuning into that and making sure we understand what our problem is wanting us to do.